Welcome back, students. In this lesson, I want to go ahead and focus on the question of which mole ratio do you use when you're doing stoichiometry type problems. And recall that a mole ratio is a conversion factor that relates the amounts in moles of any two substances in a compound. So the two substances can be on the reactant side, or they can both be on the product side, or they can be one on the reactant side and one on the product side. So it doesn't really matter, but what we're talking about is two substances. Typically those substances are compounds. They don't always have to be, but there's two parts of a reaction that are essentially being related to one another. And so let me provide you with a very brief, simple problem that we can kind of try to make sense of which mole ratio do I actually use. Okay, so let me go ahead and put that up for you. So let's look at this very basic example. Let's say we have hydrogen gas, oxygen gas reacting to form the compound water. Now, the first thing that we need to do before we even get to mole ratios is we need to actually balance it, because in balancing, that's where we're going to get the coefficients that make up a major part of the mole ratio. Okay, so when we look at this equation here and we try to balance it, we notice that we have two oxygens on the left-hand side, but only one oxygen on the right. So we are going to need to add another oxygen to the right side, giving us two oxygens. But now we notice that the hydrogens are not balanced. We have a total of 4 on the right. So I need another hydrogen molecule, or hydrogen gas molecule, over here on the left. And if I do that, now I've got a total of 4 hydrogens on both sides and 2 oxygens on both sides. And so if I do this, I count them, I know that my coefficient here is going to be a 2, a 1, and a 2. Now I don't need the rest of this, so I'm going to go ahead and erase that to get it out of the way and not to confuse us. Now that we know the actual balanced equation, we can use this to develop a relationship between two different substances, or two different parts of this entire reaction. Now we learned in previous examples that you can calculate how many of those mole ratios you're going to get. I'm going to let you go ahead and go back to that video and watch how to do that. For this video, I just want to focus on which mole ratio do I use. And in order to do that, let me give us a very basic problem that will help us figure out which one I actually use. Okay, so here is the a basic question that we've got. And so what we need to figure out, and always remind ourselves, that a mole ratio is nothing more than a fraction. It's a proportion, okay? Another way of thinking about it is that a mole ratio is nothing more than a combination between the two things that, the two compounds or the two substances that you're looking at for the problem. So based on this problem, what are the two things that I'm looking at? I'm looking at water as one item, and then the other thing that I'm looking at is hydrogen gas. So I need to come up with two different combinations. And so when I look at that, I'm looking at the hydrogen gas on the left-hand side, I'm looking at water on the right-hand side. So what kind of combinations can I come up with? Well, one combination that I can come up with is I can have this combination where I have 2 moles of hydrogen gas being used for every 2 moles of water that are produced. Another combination that I can get is when I flip them around or do the inverse. That is when I have 2 moles of water produced for every 2 moles of hydrogen gas consumed. So the question that a lot of students tend to have is, which one of these two do I use? I don't know which one. Well, it depends on the problem. So you ask yourself, which in this particular problem, and so we've got a problem here that we're using, we'll ask ourselves, which one of these two compounds or substances, hydrogen or water, is it that I am trying to find? And so if you look at this closely, you're trying to find, because it tells you right here how many moles of water. Whatever you're trying to find is what goes in the numerator. That means whatever goes on top of this particular fraction, proportion, or combination that you've just written. So when we look at these two problems here, or these two different mole ratios, which one is the one that has water on top? Well, if we look closely, this one is the one that has water on top. So this is the one I'm going to use, not this one. Okay? And if you're trying to solve this particular problem, you know, the problem is very easy to use and solve at this point. So you're going to go ahead and essentially take what you've got, the 3 moles of hydrogen gas, and you're going to multiply by the mole ratio that you've just determined to be the correct one for this problem, 2H2O divided by 2H2 And if you multiply that out, that should give you the answer that you need, because the moles of hydrogen cancel, and what you're left with in the numerator are the moles of water, which is what we're trying to find for this particular problem. Okay? So you can go ahead and do the math. 3 times 2 divided by 2, the answer here is going to be 3 moles of H2O are produced. Okay? And so this is your answer here. So it's not very difficult to identify which mole ratio you're going to use, but you need to figure out what the total combinations are, and then ask yourself, which one am I trying to find? And that's what goes in the numerator.